In the figure below, A, B, C, and D are collinear. That means they're on the same line. Segment FC is parallel to segment ED. So I'm going to put the same number of arrows. That means parallel. Segment BE is perpendicular to segment ED. That means it forms a 90-degree angle, which the picture already has. And the measures of angle FAB, which is 55, and angle EBA, which is 120, are marked. You can see those angles, they're marked. What is the measure of angle FCB? So this is what we're trying to find right here, this little guy. Well, if we extend these parallel lines like so, and we look at this transversal here, this angle right here that's 90, and this angle right here, which is at the top of this little triangle, those are corresponding angles. Corresponding angles are congruent. Let me redraw this picture down here a little bit bigger. So that means that this angle here is also 90. That's this little guy right here. So that being 90, that means that's a right triangle. If we look at these two angles, the 120 and the angle beside it, that's a linear pair. Let me blow that up over here. According to the supplement theorem, these two angles, when you add them together, have to be 180. So that's going to make this 60 degrees. So this angle here, which is here, is 60 degrees. I have a bigger picture here. The question was, what's this angle here? According to the angle sum theorem, which says if you add up all the angles in a triangle, you get 180 degrees, you could make this equation. 60 and 90 is 150. If you subtract 150 from both sides, you get angle x, which is the angle we were trying to find, is 30 degrees. Write the equation of a circle with its center at 0, 0 and passes through the ordered pair 6, 8. First of all, the standard equation of a circle is x minus h squared plus the difference of y and k squared, which equals r squared. In this case, hk is the center, and r is the radius. So part of this is easy. hk, 0, 0, is the center. So replace h, replace k with 0. If we do that, x minus 0 is x, so we get x squared. Y minus 0 is y, so we get y squared. What we don't know is what's the radius. If I take this circle that it's describing with center at 0, 0, it says there's a point on this circle that's the ordered pair 6, 8, which means I had to go to the right 6 and then up 8. That gives us this right triangle. Pythagorean Theorem tells us that if we square 6 and we add it to 8 squared, it equals the hypotenuse squared. Also, you might recognize this is a Pythagorean triple. Classic 3, 4, 5 right triangle. Notice here, if we were to multiply 3 times 2, we'd get 6. 4 times 2, we'd get 8. And therefore, 5 times 2, you'd get 10. So the radius is 10. If you square it, you get 100. That's the equation of the circle. Once again, you could also find 10 just by writing out the Pythagorean theorem and solving for the hypotenuse. Just 3 questions that go with this next part right here. Somebody from the Middle East has decided to create a triangular flower bed border. He plans to use 3 pieces of rectangular lumber with lengths 4, 5, and 6. So piece of lumber, piece of lumber, piece of lumber, length 4, 5, and 6 feet. Points A, B, and C are located at the corners of the flower bed. The dude plans to cut 3 pieces of lumber for the flower bed border from a single piece of lumber. Every time he makes a cut, he loses 1/8 of an inch. So he's got one board and he's going to have to make a cut here, he's going to have to make a cut here. He's going to make 2 cuts to make 3 pieces. What is the shortest piece in inches that he has to use to cut the piece for the flower bed border? So we need 4 feet here, we need 5 feet here, we need 6 feet here, and then each of these little cuts we're going to lose 1/8 of an inch. So if we add 4 feet, well, it says inches. 4 feet is 48 inches, 4 times 12. 5 feet is 60 inches, 5 times 12. 6 feet is 72 inches, 6 times 12. So we take 48 plus 60 plus 72 plus 1/8 plus 1/8. That's going to give us a little bit more than 180, 180 and 2/8 of an inch. We're getting a piece of wood by the inch, so we have to round this up. Your board needs to be 181 inches. Continuation of this problem. The measure of angle ABC in the figure is x. Find an expression for beta in degrees. Well, if I blow up this corner, I get this. Got x degrees here, I got beta degrees here. This angle here is 90, this angle is 90. If you sum all the angles in a complete revolution, you get 360. Therefore, if we take x degrees plus beta degrees plus 90 degrees plus 90 degrees, it has to equal 360 degrees. If you combine like terms, 90 and 90 is 180. If you subtract 180 from both sides, you get the following. It says find an expression for b, so you want to get b by itself. So beta, b, is 180 degrees minus x degrees. That's the expression. Continuation of this same figure, yada 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 yada, yada yada yada. It wants to be a right angle. He wants the right angle at vertex A. So he wants this to be 90 degrees. It says the lengths of AB and AC are still 4 and 5. What would the hypotenuse be? Pythagorean Theorem once again. A squared plus B squared equals C squared. A and B are legs. That is what makes up the 90. C is the hypotenuse. So 4 squared plus 5 squared equals C squared. 16 plus 25, which is 41. Using a calculator, square root both sides, it's about 6.4. That's what C is. And C here, more specifically, was the length of side BC. So segment BC is about 6.4 feet. Following problem, I cannot express to you how much I hate. Which of the following expressions has an even integer value for all integers A and C? Which means any integer you put into this, which of these will always give you an even answer? So I don't know a logical way to do this other than just plug numbers in and see what happens. So my goal is to try to get it to be an odd answer. If I can get it to be odd, it's not going to work because I'm supposed to get it to be even. If you can always get it to be even, it's going to work. And if you can get it to be odd just once, then it doesn't. If I were to put an odd number into this, such as a 1 for A, that's going to give me an even number, 8. If I put a 2 in for A, it's going to give me an even number, 16. So it looks like this is going to be even no matter what. This next one, I got to put the same number in. If I put a 1 in, 2 times 1 is 2. If I put, which is an even number, if I put an even number in instead of 1 like a 2, 2 times 2 is 4, still even. And I multiply it by C. So we've already established this right here is going to be even, whether I put an odd or an even. If I put a C in, let's say if I put a 1 in for that, even times this odd is going to give me an even number. If I put a 2 in, 2 times 2 is 4, it looks like this is going to work. let's be sure. Let's see if I can make the other ones become odd. 3a plus 3c. If I put a negative in for a, I get 3, which is odd. And if I put, I think I may have said negative in for a and then odd. If I put an odd in for c, I get odd. That doesn't work. Let's say I put an even in for c. 3 plus 6 is odd. So it was possible to get an odd for this, which means this one can't be the answer. You don't want to get an odd answer. It has to be even every time. If you can think of one time where it's odd, then it doesn't work. If I pick a 1 for A and a 1 for C, I get 2 and 1, which is 3, which is odd. That doesn't work. Let's try A plus 2C. I could put a 1 in here and a 1 in here. I get 1 plus 2, which is 3. That didn't work. And then finally, a times c plus a squared. If I put in a 3 times a 2, I get 6 plus 9, which is 15. So this one is the only one that appears like it's going to work. Hate that problem with a passion. A neighborhood recreation program serves a total of 300 children who are either 11 years old or 12 years old. X is the number of 11-year-olds. I'm going to say Y is the number of 12-year-olds. The sum of the children's ages is 3,500. How many 11-year-olds does the recreation program serve? Let's go back to the beginning. There's 300 children. There's X number of 11-year-olds, and there's Y number of 12-year-olds. Their sum together is 300. The second part says the sum of their ages. So if you take all the 11-year-olds, which is X, and multiply by what each of their ages, they're each 11, and you add to that the number of 12-year-olds, which is Y, and how much their age is, that's supposed to equal 3,500. This equation here is not so simple. We got two equations, two variables, so we solve a system of equations. If I get Y by itself here, and I replace this Y with 300 minus X, I get 11X plus 12 times the difference of 300 and X. If I distribute the 12 here, I'm going to get 11x plus 3,600 minus 12x equals 3,500. Combine like terms, 11x minus 12x is negative x. If I subtract 3,600 from both sides and divide by negative 1, I get x as 100. X, the number of 11-year-olds. The question, how many 11-year-olds is there? There's 100. The geometric figure shown below is a square here and 4 semicircles. One semicircle is half a circle. If you have 2 semicircles, that's a full circle. So we have we end up with 2 full circles when you put your 4 halves together. The diameter of the semicircles are the sides of the square. Each diameter is 20. So this right here is 20 centimeters. So we have a square that's 20 by 20. And we have 2 circles with a diameter of 20 and a radius of 10. Which of the following is the closest approximation of the total area? So find the total area. Keep in mind ACT is multiple choice. I took away the choices, and let's just figure out what the answer is. So to find the area of a rectangle, which is what a square is length times width. It's 20 times 20, that's 400 square centimeters. We have 2 circles, same size. The area of one circle is pi r squared. The area of 2 circles is 2 pi r squared. Radius is 10. 10 squared is 100. 100 times 2 is 200, so it's 200 pi. It says approximation. So let's take 200 times pi. Let's say pi is just 3. So it's about 600. It's actually more than that because I rounded down. If you add these together, you get 1,000. So multiple choice, you'd want an answer that's a little bit more than 1,000 if there is one, because we rounded pi down a little bit. Or you could just leave it. If you don't round it at this point and just multiply this out, this is about 628. 628 and 1,400 is 1,028. So whichever answer is closest to that. Write an expression for the height, h in feet, of the roof truss shown below. Well, this is simply a right triangle. Pythagorean theorem might work, perhaps trigonometry. If this whole bottom is 50, then that makes half of this 25. So here's what our picture looks like, getting rid of all the extra stuff. That h is supposed to be here, not there. Right angle trig. Sine of 20 degrees would be the opposite leg over the hypotenuse. Let's say that hypotenuse is c, which is not going to help us. Cosine of 20 degrees is the adjacent leg over the hypotenuse, which is not going to help us. We want to use h and the 25 and the 20. So tangent of 20 degrees is the opposite leg over the adjacent leg. This is going to help us. If you get h by itself, you can multiply both sides by 25, and you get 25 tangent of 20 degrees is h. Quadrilateral Abcd, is drawn in the standard coordinate plane. Point E and F are on segment AD. Point G is in the center of rectangle BCEF. I don't see rectangle BCEF, so let's put it in. It says G's in the center. So before I get to the question, if E is 12 to the right and C is on the same segment as that, and this is a rectangle, it means this is 90 degrees, which means the coordinates of C are 12, and then it's 4 high, 12, 4. The coordinates of F would make that 6, 0, because this up here is 6 to the right. So that's the coordinates of the rectangle. The question is, how many coordinate units long is AG? We're supposed to find this. We got to find the coordinates of G first. Since G is in the center, G is the same distance to the right of this rectangle as it is to the left. The length of this rectangle is 6. Since that's 6, that makes it 3 right here, because that gets cut in half. Then if you look at this vertical distance here, we're going from 0 to 4, which means half of that, 2. So let me blow this up, this triangle right here. This vertical distance here is 2. This horizontal distance, we have a 6 and a 3, which makes that 9. That's the segment addition postulate. We're supposed to find the length of AG. Once again, Pythagorean theorem. A squared plus B squared equals C squared. In this case, A is 9, B is 2, don't know what C is. 81 plus 4 is C squared. You get 85 is C squared, square root both sides. I need to grab a calculator. You get 9.2. That's the length of C, and C really is AG. 11. What's the x-intercept of this graph? Well, y equals x squared minus 6x plus 9. To find the x-intercept, you put 0 in for x. Pardon me, put 0 in for y. This factors. This is a perfect square trinomial. square root both sides, and then add 3 to both sides, and you get x is 3. There's one x-intercept for this, and it's 3. For all non-zero real numbers p, t, x, and y, such that this is true, which of the following expressions is equivalent to t? That means solve the equation for t. So we got this hot mess. First I'm going to get rid of my fraction by multiplying both sides by y and 4t. On the left, the y's cancel, and you get 4tx. On the right, the 4t's cancel, and you get 5py. Trying to get t by itself, t is attached to the 4 and the x by multiplication, so divide both sides by 4x, and you get 5py divided by 4x. That's what t is.